So, how about for temperature? How does it affect the rate of chemical reaction? Okay, so for example, we have 20 degrees Celsius, 30, 40, 50, so on and so forth degrees Celsius. Now, this is now the rate of chemical reaction increasing. Now, say at 22 degrees Celsius to 30 degrees Celsius, how do you describe the rate of chemical reaction? Increasing. How about, say, when the temperature is increased up to, say, 37? Say, this one here, how do you describe the rate of chemical reaction? Increasing. And then we have a maximum, say, the peak of the rate of chemical reaction, the maximum rate of chemical reaction at, say, for example, 38. How do you describe the rate of chemical reaction? Increasing. However, when you go down to 45 degrees Celsius, how do you describe the rate of chemical reaction? Increasing. Much more, when you go beyond 50, what happened? Okay, no more reaction. 1. Okay. Now, I'll give you one example, class. Now, say for example, bacterial culture. Sa bacterial culture, nasa specific temperature, we call that optimum temperature for the bacterial broth, where there is what we call as land, fine. Meaning, patubo yun, magdaghan, multiply. No? So, dapat, you have to meet the optimum temperature for your bacterial culture. So, you could achieve that, say, product for that particular culture bacteria. However, say for example, the bacterial culture requires, or say that specific bacterial culture requires, say for example, 50 degrees Celsius for its optimum broth, where you would be expecting broth in bacteria. However, you go beyond 50, abot kag 60 or 70 degrees Celsius. What do you think will happen to your bacteria?
Patay.
Okay, of course, at first, mo slow down and then later on, mamatay rin siya. If the bacterial culture will not grow, then later on, they will die. So, you have here, this is what happened, class. So, there is, in other words, in a particular chemical reaction, we call that optimum temperature required for a particular product to form in a chemical reaction. So, when you deal with chemical reaction, class, so dapat you should be particular, specific with the optimum temperature, or else you cannot get the desired product. Get it? Okay. Now, that's why sa inyo pong kuan, sa inyong mga medicines, store in a cool place with this range of temperature. Say, store at room temperature. Okay, butangin mo sa 0 degrees, you cannot expect the desired effect of your medicine. Or higher than that, init kayo, sa inabot ng 50. No? Or naabot siya 40. So you cannot expect the desired effect of your drugs or medicine. That is how important optimum temperature is in a chemical reaction. Get it? Okay. So next, how about the pH? Now when we say pH, now this is the amount of hydrogen ions. No? The concentration of the hydrogen ion in a particular molecule. So the pH. Now, it is measured as to 1 to 14. So, with a pH meter. Say if the pH is 7, meaning the molecule or the substance is neutral. If it goes beyond 7, meaning acidic. If it's higher than 7, meaning basic or alkaline. Got it? Okay. Now, with this, say for example, you have, you're increasing the pH. Say for example, from 5, naimong 6, what happened to the rate of chemical reaction? Increasing. Say 6.5. Okay, you still have increasing rate of chemical reactions. But when you go, so this one is acidic condition. This is neutral. Now here, this is alkaline condition or basic condition. Now, when you go beyond 7, which is in the alkaline condition, what happened to your rate of chemical reaction? Decrease. So the chemical reaction slows down when, of course, when you go beyond the optimum pH of your substance. Now, the same is true with, say, what I gave you. Not only temperature must be in an optimum condition, but as well as the pH of your culture. So, when you do bacterial or culturing bacteria or fungus or any microorganisms, you have to meet its optimum temperature and optimum pH. Or else, you cannot expect growth in your bacterial culture. Now, the same is true with your drugs or your medicines. So, if you're, say, moinom ka, kani, inuman ni siya, kuan, kanang, iparisi ni og, ingon ani, say, parisi ni siya, kaning, meds, say, acidic na meds, para ma-achieve ni mo ang iyang effectivity. No? Meaning, diri siya, dapat, to become efficient, for that drug to become efficient, dapat it should be in an acidic condition. Less acidic condition to achieve its efficiency. No? But if you do away as to what is optimum pH, say highly acidic or highly basic ka na, then it cannot get its desired outcome or desired product. So it will only be effective, you can produce more of this product as what you're expecting to produce when you go as to within the optimum pH. The same with your temperature. So dapat na ay optimum. Other than that, dili na siya effective. Okay? Now, the same is true with your enzymes. No? Ang mga enzymes or sa imong mga substrates, no, dili na po siya dili na po siya effective. Okay? Any question here? Okay. Now, there are some mechanisms of the action of this enzyme and the substrate activity. Okay? Now, one mechanism is this lock and key model. Lock and key model. Now, you know the lock and you know the key. Now, the lock has only one key to open up the door, right?
Yes.
Okay. So, when you use other key, it cannot be opened up. Now, there are some enzymes. There are some enzymes which are said to be very, very specific to a particular substrate. It will only be activated with that specific substrate. Other than that, it will not be activated. Kasi sa mga sahay, kung fresh ni mo, siya na hindi mong ganahan. Hindi ka ganahan, so hindi mo crash. Dulgo sa imo luod. So what makes you happy and inspired is only your crush. So we call that lock and key model. Okay? So the same is true with this. Say we have this enzyme, we have this active site or the binding site of the enzyme, specific substrate. Now, this substrate is the only substrate that could bind to the particular active site or binding site of the enzyme to become what? Activated. So once enzyme is activated, then there is now product formation in a chemical reaction. So we call that mechanism as the lock and key model.